So question number 9, the graph below shows the relationship between pressure and the temperature of a gas in a fixed volume container. From the sketch that we have, or the graph, this is pressure and this is temperature. As you can see, if we pick a point here and a point here, this point, as we move from this point to this point, meaning both pressure and the temperature will increase as we move from this given point to this given point. So meaning pressure is directly proportional to temperature, or temperature is directly proportional to pressure. What does it mean? It means that as the pressure increases, also it will affect the pressure. The pressure also will increase. So this variable, that is pressure and temperature, they are directly proportional to each other, because the increase in temperature will affect the pressure. The pressure also will increase at the same time. B, using kinetic theory, explain the relationship shown in the graph. I think we remember the kinetic theory of matter. Now, if we want to use the kinetic theory to explain how these two variables affect each other, we can say, as we increase the amount of energy to the particles, these particles will gain the heat energy. Then at some point the heat energy will be converted to kinetic energy. The kinetic energy increases the vibration of these particles. These particles will collide each other and will collide the walls of the container. As they collide to each other, the walls of container, they exert more pressure. Remember, increase in temperature, the kinetic energy increases. The vibration also at the same time increase. As the vibration increases, they will exert more pressure to each other as they collide and to the walls of container. So as the temperature increases, also the pressure will increase. As the temperature reduces, the kinetic energy tends to reduce of the particle. Hence, the movement, the speed of this particle will also reduce. As the speed of the particle reduces, meaning less pressure will be exerted to each other and to the walls of the container.